Welcome to this course in ordinary differential equations. Let's begin by some terms. Differential equation is an equation that contains one or more derivatives of an unknown function. For example, this is a differential equation. The presence of this derivative dy over dx makes it a differential equation. Then we have ordinary differential equation. If all the derivatives are ordinary derivatives of a function of one variable, and these are the derivatives that we study in Calc 1 and Calc 2, we just study ordinary derivatives in these two courses. So all the derivatives that you see there are derivatives of a function of one variable, because generally you'll have y as a function of x and you're taking the derivative of y. So if those are the only derivatives involved, then it's called an ordinary differential equation. So for example, this one is an ordinary differential equation. And besides the ODEs, we have the partial differential equations in which partial derivatives are involved. And this course is only about ordinary differential equations. So I wouldn't define the partial differential equation, although the definition is very similar. We will use partial derivatives on just a few occasions in this course, but they will be needed while solving an ODE. We will not study PDEs in this course, the partial differential equations. So next is order of a differential equation. The order of a differential equation is the order of the highest derivative involved. So for example, in this differential equation, the order is 2 because the highest derivative we see is the second derivative. And the order of this second derivative is 2, and that's why the order of this differential equation is 2. Whereas over here, the highest derivative that we see is the first derivative, so the order of this differential equation is 1. Okay. So an order of a differential equation is very similar to the degree of an equation. Degree of an equation, you just look at the degree of the highest power of the variable. You just look at the highest power of the variable. In this case, we look at the highest order of the derivative. Then we have linear differential equation. So a differential equation in which you have only derivatives and the dependent variables of power 0 or 1 is called a linear differential equation. So for example, this is a linear differential equation because y is the dependent variable, its power is 1. And then if y was missing, then if y term was missing, then its power is 0. That's fine as well. And then we have this derivative dy by dx. Its power is 1. And then we have this derivative d squared y over dx squared. Its power is also 1. Remember, its order is 2, but its power is 1 because we don't have d squared y over dx squared whole power something. We just have plain d squared y over dx squared. So that's what we mean by all the powers need to be 0 or 1. No fractions, no higher powers. And then there should also be no products of derivatives with themselves or derivatives with variables or variables with themselves. And only the dependent variable, x is fine. So for example, this is not a linear differential equation because we have product of y with itself. Or we can say that the dependent variable is appearing to power other than 0 or 1, that's power 2. These two terms are fine, but this term makes it a nonlinear equation. Similarly, if there was like a y times dy by dx, that also makes it nonlinear. You can't have products of the dependent variable and the derivatives. And then you can't have the products of derivatives with themselves as well. So you couldn't have a term which has a dy over dx times d squared y over dx squared. So in other words, all the terms, if you look at them individually, so like this is a linear equation, every term should have a dependent variable to the power 0 or 1, or a derivative to the power 0 or 1, and it shouldn't have a mixture. Now the independent variable is fine. So for example, if I, let's say, add an x cubed to this one, it still is a linear equation, because although x is appearing to power 3, which is not 0 or 1, but yet x is fine, because our definition is only requiring the dependent variable to appear to power 0 or 1. So this is fine. This is still a linear equation. But if you put anything on the power of y, then it becomes nonlinear, anything other than 0 or 1. So now let's look at a few problems in the exercise. So 1.1. So let's see, classify the given differential equation. So let's see, it is ordinary, because only ordinary derivatives are involved, no partial derivatives. And its order is 4, because the highest derivative is the fourth derivative. But okay, they're not asking the order yet. Here, the choice is, it's not a partial differential equation. And let's see, is it linear or is it non-linear? So this derivative is appearing to power 1. This derivative is also appearing to power 1. And here the so it's dt by dy. So the dependent variable is t in this case, and so 6t. So that's also power 1 for the t. And the other term we don't care, because that's for the independent variable. So this is fine. Everything about linear equation is satisfied, and this is a linear ordinary differential equation. Then what's the order of this differential equation? The order is 4, as we discussed earlier, because the highest derivative is the fourth derivative. And then the independent variable is y. So whatever is the bottom variable in the derivative, that's the independent variable. And the dependent variable is the top derivative. So remember, in dy by dx, y is the dependent variable. So it's a dependent variable only because it's appearing on the top. And okay, number 2. So what is this? Now here, you see that if you open up this equation, this will be y minus 7qy divided by q. So here, first let's see which one is the dependent variable. The dependent variable is y. So at some, when you open this up, you get y minus 7q, and then you have a q in the bottom, and you have a y appearing in the denominator. So a y appearing in the denominator is like appearing to the power other than 0 or 1, because you can roughly think of it that if you bring this up, this will be y power negative 1. And this won't, it won't completely cancel. This term cannot completely cancel out with what we have on the top. If it did, then this would be linear. But because there's this y term sitting in the bottom, which cannot be written as a power of 0 or 1, because it comes up as a power negative 1. So in that definition where we said that the power is 0 or 1, it's understood that we're talking about the power when the term appears in the numerator. So this one is nonlinear because of this denominator y. Then now the denominator q is fine because the q is the independent variable. So this is fine. We don't worry about that. But the y in the denominator makes it nonlinear. And it's still an ODE. The order is 2 because the highest derivative is the second derivative. And the independent variable in this case is q and the dependent is y. Remember, dependent variable is the top of the derivative. Okay. So let's see. So now here, when you multiply this, the first term would be y, and the second term would be y times dy by dx whole squared. And even if that was not the case, so it's nonlinear for two reasons. Because first of all, this derivative is appearing to power 2. Remember, we said that the derivatives should appear only to power 0 or 1. But even if this derivative was power 1, when you multiply the y times dy by dx is going to make it nonlinear. So it's nonlinear for multiple reasons. So nonlinear. The order is 1 because the highest derivative is the first derivative. So the order is 1 in this case. And the independent variable is x, the dependent is y. And this one, okay, so when you multiply this out, this is 4p minus 7p squared. But p squared is fine because p is the independent variable. Remember, we shouldn't have a q square, but p squared is fine. And similarly, this derivative is appearing to power 1. It's a second derivative appearing to power 1. So this is linear. And the order is 2 because the highest derivative is 2. And the independent variable is p. The dependent variable is q. Okay, so that finishes the section.